Hello, welcome to the Linear Algebra Tutor. Here we're going to talk about finding the determinant of a matrix, and we're going to start the process of learning how to find the determinant of a matrix using row operations. So many of you watching this have probably encountered the concept of the determinant of a matrix already in your prior studies. What we're going to do here is go over the same kind of general idea of what a determinant is, and then we're going to show you how to take the determinant using row operations, which is something you probably haven't seen before. There's more than one way to take determinants. In fact, there's lots of different ways to take determinants. The method that we're going to use here is something that every single person has to learn in a linear algebra class for sure. And it has its place and it has its usefulness for sure. But there's another method that I'll teach you in a few lessons from now that'll be, in my opinion, even more useful in a day-to-day situation. But for now, let's just kind of go over the general idea. A determinant of a matrix is a number that you calculate, and it's used in lots of different situations. You can use it to solve systems of equations. You can use it when you're doing eigenvectors and eigenvalues, which we'll get to later. You can use it in lots of different ways, even in differential equations. Sometimes you'll have a system of differential equations, and you can use the determinant to help you figure out if that system of differential equations has a solution. So determinants here, we're just going to be dealing with numbers in a matrix, but just keep in mind that they're used in lots and lots of different applications. So I want you to recall that for a 2x2 matrix, we have studied what we call the inverse. So for a 2x2 matrix, for instance, we might have A, B, C, and D. These are just numbers I'm using to represent letters right now. And we've actually already covered this in the previous volume of linear algebra. But the inverse, we said A to the negative 1. And we said that that was AD minus BC, 1 over that. And then you take that number and you multiply by D, negative B, negative C, and A. And so what you do is using these numbers here, you put them in their positions, you put the negatives there, you calculate this fractional thing, you multiply it, and that matrix that you get out of that is called the inverse matrix. And we've used the inverse all the time. Now what I didn't really tell you at the time is that this little part that's stuck underneath the bottom of the fraction here, this is actually the determinant, of a 2x2 matrix, okay? Not the 1 over part, just this guy right here. So to formalize, the determinant, sometimes you write it as det, of a 2x2 matrix where we represent A, B, C, and D, meaning these numbers in these positions, is equal to A times